Hello everyone. In this video, we're going to be solving a trigonometric equation. If you like this video, please comment, like, and subscribe, and don't forget to hit the bell button for notifications. And let's get started. Now, this equation is a little different from the other ones for a couple of reasons. First of all, I haven't seen this problem being solved anywhere on the internet. If there's a video, please let me know down in the comments section because I haven't seen it. I kind of searched for it, like if anyone else has done this before. So it's probably the first. Second, this is a quintic. That's what makes it interesting, and we'll get to that later as well. Okay, cool. Let's get started. Now, I do have sine to the fifth power of x and cosine to the fifth power of x is equal to 1. So basically, you may just guess and check some solutions here. Obviously, sometimes that works, but that's not the goal here. We're going to dive right into this, and we're going to be doing a lot of algebra here. Okay. So first thing that I'm going to do here is, and I think this would probably go a long way in terms of solving trigonometric equations, is I'm going to use substitution. But before I get into that, I'm going to call something special. So that's going to be the sine x plus cosine x. You know that it's a very special expression for many reasons. First of all, this is important because you can square both sides, like you can square sine x plus cosine x, and you'll get a nice expression like sine 2x, so on and so forth. So this expression in trigonometry is extremely important. And of course, I will go into more details. So I'm going to call this one u, and you'll know why I'm calling that u. Okay? So first step that I'm going to do is I'm going to square both sides, like I was saying. So let's go ahead and do that. Let's square both sides, and we're going to be getting something nice because this gives us sine squared x plus cosine squared x. I'm just doing the squares first, plus 2 sine x cosine x, right? And as you know, this is equal to sine 2x, but that's not what we're trying to do here. We're just going to leave it like that. And as you know, the most important identity in trigonometry is probably sine squared x plus cosine squared x being equal to 1. So this is 1, the Pythagorean theorem. And then from here, we can basically get the sine x cosine x by itself. So we can isolate it. If you subtract 1 from u squared, you're going to get u squared minus 1. And if you divide by 2, that should give you u squared minus 1 over 2. So that's going to be my first expression that I'll be using, sine x times cosine x. Okay. Now, the second thing that I'm going to do, and you might be saying, like, what does this have to do with fifth power? We'll get to that. Okay. The second thing that I'm going to do is I'll take the sine x plus cosine x. I'm going to write that again. Okay. So I'll have sine x plus cosine x. And this time, I'm going to be cubing both sides. Okay. So let's go ahead and cube both sides. Now, when we do that, something interesting is going to happen. Let's see what happens. And for the cube, again, there are so many ways to approach it, but I'll probably take this approach. Sine cubed x plus 3 sine squared x cosine x plus 3 sine x cosine squared x. As you know, a plus b quantity cubed from binomial theorem plus cosine cubed x. And this should equal u cubed. Now, take a look at this. Sine cubed x plus cosine cubed x. I want to isolate that, sort of. So I want to put those together because that's something that I'd like to use later on. And then these two terms in the middle, and that's another identity. You can write it that way too in the beginning. You can take out the common factor, which is 3 sine x cosine x. So I could pull that out. And then inside the parentheses, I should have sine x plus cosine x, which is something familiar, right? Okay. So that is equal to u cubed. Now, what am I going to do with this? Well, I kind of know, not kind of, I actually know what sine x cosine x is in terms of u, and this is just u. So if you do all the replacements, then you should be getting sine cubed x plus cosine cubed x in terms of u, which is what I was trying to do. Okay, cool. Let's proceed with that. So what I'm going to do is I'm going to isolate this guy over here. So sine x cosine x, right there, it is equal to u squared minus 1 over 2, and this is just u, and the whole thing is equal to u cubed. So what I'd like to do next is basically subtract this term, the 3 times u squared minus 1 over 2 times u, from u cubed, so that I can get sine cubed x plus cosine cubed x by itself. That was my goal, okay? So let's go ahead and do that. So this is going to give me u cubed minus. So if you go ahead and distribute the 3u, you should be getting 3u cubed minus 3u divided by 2. Of course, we can do a little bit of work here because you can make a common denominator. Let's simplify this a little bit so it looks nicer. You know, sine cubed x plus cosine cubed x is equal to 2u cubed minus 3u cubed. That's going to give me a negative u cubed. But then I'll have a 3u, so I can write that first. 3u minus u cubed divided by 2. So that is my expression for sine cubed x plus cosine cubed x. Now, I think we're ready to tackle sine to the 5th plus cosine to the 5th. Let's go ahead and put it all together, and then we're going to get a nice expression from here. Well, kind of nice. Okay, let's see what happens. Now, the next thing I'm going to do is I'll take this, and of course, not use it directly, but indirectly. And I'm going to take the sine x plus cosine x being equal to u. So if you write that again, so sine x plus cosine x is equal to u, as you know, right? So what I'd like to do now is I'm going to raise both sides to the 5th power. And let's see what happens. It's just experimentation sometimes, right? You don't necessarily have to have a strategy in the first place. You can just experiment. Okay, so let's go ahead and raise both sides to the 5th power, and let's see what happens. Now, when you raise something to the 5th power, again, we're going to use the Pascal's triangle, you know, the binomial theorem, the combinatorial, what is it called? Binomial coefficients, whatever they're called, doesn't matter. What matters is that that row gives us 1, 5, 10, 10, 5, and 1, correct? Because the previous one is, remember, 1, 4, 6, 4, 1. And what you do is you basically add the 1 and the 4, 4 and the 6, 6 and the 4, 4 and the 1, and you start with 1 and you end with 1. So that's how you get each consecutive row. Okay, so those are going to be my coefficients. So the coefficient for the first one is just going to be 1. And then I'll use a 5, sine to the 4th. And the powers of sine are going to go down as the powers of cosine go up. Okay, so that's going to be a cosine x, a single one. And then I'll use a 10. And you'll see some symmetry too with the coefficients and the powers. For example, for this one, I'm going to be getting sine cubed cosine squared. For the next one, they'll just be switched, and it's going to be sine squared cosine cubed x. Why? Because they have to add up to 5. Okay, and then I have the 5. I don't think it's going to fit here, so I'm going to have to use the second row, which is okay. I don't want to make it too long anyways, right? And this is going to be a 5 sine x, and then I have cosine to the 4th power. Again, we have the symmetry with this term here. Plus, we're going to end with cosine to the 5th power. Now, what's really important here is that we're going to put these together in a meaningful form. And of course, this whole thing is equal to u to the 5th power, which we'll get to that later. Okay, so now what I'd like to do is, because my goal, remember, in my original equation, I have sine x to the 5th power and cosine x to the 5th power. So I want to put the first and the last terms together, which of course makes sense, right? Yep, so let's go ahead and do that. I'd like to maybe switch here. Okay, so I'm going to write it as sine x to the 5th plus cosine x to the 5th. Cool. Now, those two are taken care of. What am I going to do next? Well, I'm going to put the terms with the 5 as a coefficient together because it makes sense. First of all, they have the same coefficients and they're symmetrical. Not only 5, but I can pull out a 5 sine x cosine x from there, which is a common factor, right? And inside, which is kind of interesting, right? We're going to get sine cubed x plus cosine cubed x, which is something we found, correct? Cool. All right. So, and then we have the terms with the 10 in front of it, right? So they can also be factored. And I'm going to write them as 10 times sine squared x cosine squared x because that's my common factor this time. And inside the parentheses, I should be getting sine x plus cosine x. Awesome. So basically, we put everything together, and then this should equal, again, to u to the 5th power. Now, hopefully, this is going to be resolved anytime soon, but let's see how that does. Well, first of all, I got the sum of 5th powers. I have the product sine x cosine x. I have the sum of cubes. I have the square of the product or product squared, whatever. And then I have the sine x plus cosine x. So everything looks good. What I'd like to do is I'd like to substitute everything in place. So I'm going to keep this guy over here, of course, by itself. Sine x to the 5th, cosine x to the 5th. Plus, I'm going to replace sine x cosine x with something, right? What was that? It was, not that one, okay? It was u squared minus 1 over 2. Great. Okay, so that's going to be u squared minus 1 over 2. Okay, cool. What is sine cubed x plus cosine cubed x? That is equal to 3u minus u cubed over 2. Let's go ahead and do that. And obviously they are multiplied, right? So don't forget that. It's going to be 3u minus u cubed over 2. That takes care of the cube. Plus, now I have sine squared cosine squared, which is sine x cosine x quantity squared. So what I'd like to do is I'll take this expression here and square it. Okay. I told you there's going to be a lot of algebra here. And then times sine x plus cosine x, which is u. And finally, it's u to the 5th power. So what happened here is that we were able to get sine x to the 5th plus cosine x to the 5th in terms of u. But we need to simplify this a little bit. Okay. And then hopefully we can go from there. But what is really critical is that in the original problem, this was given as 1. So I can basically replace it with 1. And I'm not trying to find that sum because I already know it's 1. I'm trying to find u here. What is u? U is, well, I'm not finding u, but it's going to help us. Okay, let me put it that way. So we're solving for u first. Okay, cool. So this is 1. Nice. And, you know, you can just simplify this. How are you going to simplify that? Well, it looks like 4 is going to be, okay, let me write it first this way, and then I'll take care of the 4. So I should be getting something like this. That divided by 4 plus, and I'm going to subtract 1, don't worry about that. This should give me 10u multiplied by u squared minus 1 squared. Oops, that looks like an h, which I don't like. Okay, u squared minus 1 squared divided by 4. There's a 4 there. Don't worry about it because that makes a common denominator. And of course, we took care of the u. And then u to the 5th minus 1. I subtracted the 1 from u to the 5th. Now, to clear our expression, to make it a little better looking, we can multiply everything by 4. So that way we'll get rid of the fractions. And it's going to look like this. So, and I can start distributing this. So this is going to be 3u cubed minus u to the 5th minus 3u plus u cubed. You got to do it very carefully because if you mess up, then it's going to mess up the whole thing. And this guy over here is going to multiply 10u by u to the 4th minus 2u squared plus 1. And of course, 4 cancels out and multiply 4 by this expression here, 4u to the 5th minus 4. Okay, so everything was multiplied by 4. Everything looks good. Let's go ahead and simplify this more. Okay, so I use the distributive property here. Let me check my work one more time. 3u cubed minus u to the 5th minus 3u plus u cubed, so on and so forth. Okay, looks good to me. And then let's distribute here. Let's see what we get. 15u cubed. And obviously, you might want to do this like these two add up to 4u cubed. So let's go ahead and consider that because I don't want to take an extra step here. It's been already too long. I don't want to make it too long. So 4u cubed multiplied by 5, that's going to be 20u cubed. Minus 5u to the 5th minus 15u plus 10u to the 5th minus 20u cubed plus 10u, right, equals 4u to the 5th minus 4. Awesome. Now what I can do is I can basically combine like terms, put it all together, and let's see what's going to be the bigger side. So I can basically put everything on the left-hand side because I'm getting a positive 5u to the 5th from here. If you subtract 4u to the 5th, that gives you u to the 5th, which is cool. Then I'll take care of u to the 4th. Do we have any u to the 4th? Nope. That's kind of nice because it's going to be a reduced quintic. And then I'm going to be looking for u cubed, and 20u cubed and negative 20u cubed also cancels out. That's interesting. Do we have any u squared? Nope. That is also interesting. What about these two? Negative 15u plus 10u is going to give me negative 5u. Wow, that's pretty interesting. And then finally, I have my constant, positive 4, because I'm adding 4 to both sides. Awesome. Okay, that's my expression. It is a quintic. Now, I told you that this is an interesting problem because it has a quintic, but now we end up with a quintic equation, but it's very much reduced. Look at that. It's like a very special quintic. But that's not the only reason why it's special, is because you probably already noticed, maybe you haven't, but I use this idea in other videos as well. If you look at the sum of the coefficients, you'll notice that they add up to 0. Wow, that's interesting. If this is a polynomial like p of u, P of 1 is 0, which means u equals 1 is a solution, which means this is divisible by u minus 1. Okay, so what is the big deal about it? Well, it means that it's factorable. So let's go ahead and make it factorable like this. I can write it as u to the 5th minus u because you know that it's going to be divisible by u minus 1. When you take out the u, it's going to be u to the 4th minus 1, which is the difference of two squares, blah, blah, blah. And then minus 4u plus 4. Now, this also verifies that it's divisible by u minus 1 because if you do the math, you'll see what I'm talking about, okay? Yep, I talk too much. I know that. Okay, I always, talk too much. Okay, cool. Let's see. All right, so this is how I can factor this, and notice that u minus 1 divides both of these pieces, which means it's going to be a common factor, which we already verified. So now I'm going to be doing a lot of factoring here. Obviously, u squared minus 1, u squared plus 1, and then this is going to be minus 4 times u minus 1, and then u squared minus 1 can be written as u plus 1, u minus 1, and then we have u squared plus 1, and then minus 4 times u minus 1. Finally, I can go ahead and take out the u minus 1 because that's a common factor, but you'll end up with a surprise here. Let me do the work first, and then I'll show you. U minus 1 is a common factor, so we'll pull that out. This is going to give us u squared minus u multiplied by u squared plus 1 minus 4. And then if you distribute the expression inside the parentheses or brackets, whatever, u to the 4th plus u cubed plus u squared plus u minus 4, which is, that's also interesting. Why is it interesting? Well, because if you look at the sum of the coefficients, it's 1 again. Wow, that's interesting. Okay, so we're going to be able to factor this again, but how are we going to factor it? Like this, u to the 4th minus 1, u cubed minus 1, u squared minus 1, and finally u minus 1. Notice that they all have u minus 1. At the end, I'm going to set it equal to 0. Don't worry about the zeros. I don't want to keep writing the 0. Stop notability. Stop doing that, okay? All right. So it's probably the way I'm using it. Just always mess up with the zoom in and zoom out. Anyways, so what does this give us? Well, notice that they all have u minus 1. So let's not keep this story too long. So u minus 1 will be taken out. When you take out u minus 1, remember this is going to have u squared minus 1 and u squared plus 1. So u squared plus 1 is going to stay there. Also, the u plus 1 is going to stay there. So this is going to be part of the equation. And then from the u cubed, I'm going to be getting u squared plus u plus 1 because that's how you get the difference of two cubes. U squared minus 1 divided by u minus 1 is going to give me u plus 1. Finally, I'm going to be getting a 1 here. Okay, now to keep a long story short again, I'm going to write this as u minus 1 squared, okay? And then the other expression is going to look like what? Okay, so this is going to give me u cubed plus u squared plus u plus 1. Then I have to add u squared plus u plus 1 to it. And then I have the u plus 2. Great. So I can probably just line them up and add like this. And the other factor is going to look like this. U cubed plus 2u squared plus 3u plus 4 is equal to 0. Finally. So you might be asking like, okay, we got a quintic. U equals 1 is a double solution. It's a double root. We took it out. Now we have a cubic. What are we going to do? Okay, let me tell you something. Cubics are not that hard to solve. If you solve this cubic, you're going to get two complex solutions and one real solution. Are you wondering what that solution is? Well, first of all, let's do the following. Let's call this u1 equals 1 and u2 equals 1. Those are the first two solutions. Now, u3 is going to be from the cubic. So if you are wondering what u3 is going to look like, I'm going to give you what it is. And then because I need to talk about it. 1/3 of something. And I'm not simplifying this because it's fine that way, I guess. Divided by the cube root of, you're going to love this because this is a beautiful expression. And obviously, you know that the cubic equations can be solved. You know, there's a formula and there are ways to solve it. So, you know, that's kind of interesting, right? Okay, this is u3. You like that? Okay, what does it look like though? Well, this is what it looks like. Exactly u3. One of the solutions, the real solution of the cubic. Do you like that? Well, could it be the answer? No. I'm going to tell you no why. Because u3 is approximately negative 1.6506. Wow, he's a human calculator. No, I'm not a human calculator, but there are some calculators available. Anyways, so this is u3. And what is the problem with that? What is u? Wow, we lost track, right? What is u? Well, sine x plus cosine x is u, right? Can sine x plus cosine x equal this value? No, because the maximum u value is root 2. And this is unfortunately, or the minimum is negative root 2. So this is less than the minimum value of this expression here. This is obviously less than negative root 2. So it's not valid. How do I know it's root 2? Well, you should probably know that if you have a sine x plus b cosine x, then the minimum expression, the minimum value is the square root of, or the maximum is square root of a squared plus b squared, and the minimum is the negative of that. So this root is not valid, which means we are left with one root only, and that is u equals 1, which means, to keep a long story short, sine x plus cosine x needs to be 1. Ooh, I forgot to say, we're looking for solutions on this interval, 0 to 2 pi. 2 pi is not included, okay? So we're only going to be interested in the one cycle. We're not going to repeat things. And if you look at this equation, how do you solve this equation? There are many ways to solve it. But if you think about it, sine x can be 1, cosine can be 0, or vice versa. Can you have like a 0 and negative 1? Yes. Now, this equation can also be solved. Now, what you can do is you can basically square both sides. You're going to be getting 1 plus 2. Okay, I could probably... 1 plus sine 2x is equal to 1. From here, we get sine 2x is equal to 0, right? And you know that on the unit circle, this is where sine is equal to 0, at 0, and pi. So you can basically, what you can do is you can say that, oh, okay, 2x is going to equal 0 plus n times pi, because all multiples of pi are just going to work. And if you divide both sides by 0, then you'll be getting x equals n times pi over 2. This is basically telling you that, okay, at every corner here, you're gonna have a solution. Why? If x is 0, cosine will be 1. Okay, if x is pi over 2, then sine will be 1 and cosine will be 0. At pi, you're gonna get, okay, oh, here's the problem, right? No, it doesn't work. Why? Because here's the problem. When you square both sides, not all solutions are going to work, right? So this is not going to give you all the solutions. So what you need to do is actually carefully look at this. You only have 2 solutions, and those are 0 and pi over 2. Those are the only solutions for x, because the others are popping up. They are extraneous solutions. Okay? I hope you enjoyed the video. Sorry about that. It was a little longer than expected, but I hope you enjoyed it. This was a really good problem that I was thinking about making a video on for a long time. And I'll see you tomorrow in another video. Until then, be safe, take care, and bye-bye.